Good morning students. Today we are going to see a new topic called anti-anginal agents. Before that, first we'll see what is angina, that is angina pectoris. Okay. In Greek it can be called the choke. So it describes the pain or discomfort of cardiac origin that results in temporary ischemia of the myocardium. What is ischemia? Insufficient supply of oxygen. That is, here the flow of the blood is not sufficient to maintain the heart's demand for oxygen and nutrients. Okay. Otherwise we can say this is due to less supply of oxygen or more demand of oxygen. Here the pain that radiates from pericardium to the left shoulder and down the arm. How it is going? Pericardium to the left shoulder and down the arm. This is pericardium, not myocardium. Okay. Now we will see the difference between pericardium and myocardium. Myocardium, that is the muscular layer of the heart, and that is made up of heart muscles and is responsible for heart contractions, whereas the pericardium, that is the fibrous encase of the heart and is made up of connective tissue and is responsible for protection of the heart. So myocardium is responsible for heart contraction and pericardium is responsible for protection of the heart. So how the pain is radiating from pericardium to the left shoulder and down the arm. Now we will see about anti-anginal agents. They are used in the management of angina by reducing the demand of oxygen or increasing the supply of oxygen or dilates the coronary arteries. So what about the role? Reducing the demand of oxygen or increasing the supply of oxygen or dilates the coronary arteries. Now we will see the classification of anti-anginal agents. The first one is nitrites and nitrates. Under that, examples are amyl nitrite, isosorbide dinitrate, nitroglycerin or glyceryl trinitrate, erythritol tetranitrate and Pentaerythritol tetranitrate. Second type is calcium channel blockers. In that four subtypes would be there, that is 1,4-dihydropyridines, phenylalkylamines, benzothiazepines and diaminopropanol ether. Under 1,4-dihydropyridines, all the dipins are coming under that, that is nifedipine, nimodipine, nicardipine, nizoldipine, nitrindipine, 5N, all are ending with dipine. Okay. So nifedipine, nimodipine, nicardipine, nizoldipine, nitrindipine, amlodipine, felodipine, isradipine. So these are all coming under 1,4-dihydropyridines. Now under phenylalkylamine, verapamil. Under benzothiazepine, diltiazem. Under diaminopropanol ether, bipridil. Okay. We will see the third type, that is beta adrenergic blocking agents. Examples are propranolol, esmolol, sotalol, metoprolol and atenolol. Under sodium channel blocker, only one drug, that is called ranolazine. Under potassium channel opener, nicorandil. Under antithrombotic agents, aspirin, dipyridamole, clopidogrel and thioclopidine. The last type is cardiovascular agents. Under that, digoxin, digitoxin, deslanoxide and quabine. So how many types are there under anti-anginal? First one is nitrites and nitrates. Second one, calcium channel blocker. Third one, beta adrenergic blocking agents, sodium channel blockers, potassium channel openers, antithrombotic agents and cardiovascular agents. Now we will see the first one, that is nitrovasodilators. So under nitrovasodilators, nitrites and nitrates are coming. Okay. So here this organic nitrates, they are the pharmacological sources of nitric oxide, that is this NO for the body. But in cardiovascular system, this nitric oxide is produced by vascular endothelial cells by means of semi-essential amino acid called L-arginine and also with the help of an enzyme called NO synthase. So this nitric oxide is secreted from this endothelial cells by means of L-arginine and also by using NO synthase. We are getting nitric oxide. This nitric oxide activates guanylate cyclase and we are getting activated guanylate cyclase. That one converts GTP into cGMP. So the level of cGMP would be increased by means of activated guanylate cyclase. This one activates the cGMP dependent protein kinases and that phosphorylate myosin light chain kinase into a phosphated one and causes its inactivation and therefore there may be muscle relaxation. So from endothelial cells by means of secretion of nitric oxide, so what you are getting, muscle relaxation, smooth muscle relaxation would be there. So here what is the role of nitrovasodilators? They are the drugs that mimic the actions of this endogenous NO by releasing NO or forming NO within the tissues, and finally causes vascular smooth muscle relaxation. So that is the mechanism of nitrovasodilators. Now we will see the drugs under nitrovasodilators. The first one, that is called amyl nitrite. So this would be the formula: CH3 twice, CH, CH2, CH2ONO2, or this can also be written like this: CH, the first CH, that is connected with 2 CH3, CH2, CH2NO. So this part, no. So how many carbons are here? 4 carbons are here. That's why it is a butane. So with the butane, what are all attached? The first position, this NO is called nitroso. Nitroso oxy group is attached in the first position, and third position methyl would be attached. That's why it is called 3-methyl 1-nitroso oxy butane. Otherwise, totally this can be called isopentyl. 5 carbons, but the first carbon, no, that is connected with one more CH. That's why it is called isopentyl. So isopentyl nitrate or isoamyl nitrate or nitramyl. We'll see the uses. Used in the treatment of heart diseases as well as angina, and also as an antidote for cyanide poisoning, as a cleansing agent and solvent in industrial applications, and it replaced dichloro-difluoromethane. Okay. Now we'll see the second drug, that is called nitroglycerin. CH2ONO2, CHONO2, CH2ONO2. So we have known that this, we have known 3 carbons with the alkane, that is called propane, that is having OH, I mean hydroxy groups in the 3 carbons, means that can be called 1, 2, 3 propane triol. So that is treated, that is added with this nitrate. That's why it is called 1, 2, 3 propane triol trinitrate. Okay. Now we will see the synthesis. Starting material is glycerol. The glycerol, that undergoes nitration by means of nitric acid and sulfuric acid at 10 to 20 degrees centigrade. What happens? This should be nitrated. So here the H is replaced by means of NO2. So we are getting nitroglycerin. Stimulates the production of coronary collateral circulation and also prevent the experimental myocardial infarction by coronary occlusion. Now we will see the third drug. That is called Pentaerythritol tetranitrate. So what is the structure? C. In center we have C, and the carbon is connected 4 sides by means of CH2ONO2. So CH2ONO2, CH2ONO2, CH2ONO2. So this is the structure. Before that, we'll see what is erythritol. Erythritol means that is having 4 carbons, and the 4 carbons are connected with OH. So CH2OH, CHOH, CHOH, CH2OH. So the 2 corners, no, that is CH2OH. In center we have CHOH, CHOH. That can be called erythritol. The chemical name for erythritol is, this is butane. I mean 4 carbons with alkane, no, that can be called butane, and 4 are connected with OH. That's why it is called butane. 1, 2, 3, 4 tetrol. So this is erythritol. Now pentaerythritol means center we have carbon, and the carbon is connected to 4 CH2OH, that is called pentaerythritol. The chemical name for pentaerythritol is, here we have chosen this as a parent, carbon, here CH2, here CH2. So CH3, CH2, CH2. This is the parent. That's why it is called propane. And in the second position, no. So what is attached? 2 sides we have 2 OH CH2. So bis, everything here second position would be attached. That's why 2 bis hydroxymethyl, and here this is propane, and with the propane first and third carbon is connected with OH. That's why propane 1,3-diol. So what is the chemical name of pentaerythritol? 2 bis hydroxymethyl, close bracket, then propane 1,3-diol. So that is the chemical name. So with that, what is attached? NO2 would be attached. So it should end with tetranitrate. And next drug is isosorbide dinitrate. So this is the structure. Fusion of 2 5-membered rings, and each is having oxygen. So oxygen, I mean first and fourth position is having oxygen, and third and sixth would be having ONO2. So this is isosorbide dinitrate. Before seeing the chemical name of isosorbide dinitrate, first we'll see the synthesis. That is this one. This is the starting material. What it is? Glucose. Already we have known this is the glucose, D-glucose. So what is the structure of D-glucose? We have 6 carbons. Okay. Here CHO, here CH2OH. In center CHOH, 4 times CHOH. This is glucose. This undergoes reduction. This is aldehyde. Okay. Aldehyde will be reduced to give. Already we have known primary alcohol on oxidation. What you are getting? Aldehyde. So aldehyde on reduction, what you are getting? Primary alcohol. Here we have aldehyde. So this aldehyde, no, that is reduced and we are getting primary alcohol, that is CH2OH. Okay. So this is called D-sorbitol. What is the difference between D-glucose and D-sorbitol? In D-glucose we have aldehyde. Here in the case of D-sorbitol, instead of aldehyde, what we have? Primary alcohol we have. This is otherwise called D-glucitol. Okay. Here by means of H2SO4, this is a dehydrating agent. Here what happens? Two molecules of water will be removed. Here one HOH, here HOH. So two molecules of water will be removed and there may be cyclization, we are getting that. Now we will see how we are getting isosorbide. Here we have CH2O. So this is CH2O, then CH, this is CH. So CH2O is this one, CH2O, this CH, this is this CH, then CHOH, okay. Then again CHOH, this is CHOH, then again CH, then CH2O, CH2. So cyclized and we are getting isosorbide. So how we are getting isosorbide? From D-glucitol, by replacing two molecules of water we are getting isosorbide. That one on nitration, the 2OH, no, that is replaced by means of ONO2. That's why we are getting isosorbide dinitrate. So how we are getting isosorbide? By replacing two molecules of water from glucitol or D-sorbitol. Okay. So removal of water can be called anhydration. How many molecules of water will be removed? Two molecules. That's why di-anhydro. So this is called di-anhydro D-glucitol dinitrate. While numbering, this is 1, 2, 3, 4, 5, 6. Where we have oxygen 1 and 4. That's why 1, 4. And this ONO2 group is attached at 3rd and 6th. That's why 3, 6. So 1, 4, 3, 6. Two molecules of water will be removed to get this one from glucitol. That's why di-anhydro D-glucitol dinitrate. Otherwise we can write 1436 di-anhydro D-sorbitol dinitrate. That's all. After this we have completed nitrovasodilators.